We're going to be talking about potential dividers. Okay, so what did potential dividers do? So what they do is that they vary the potential difference of an output from a component. So from a component. So if I was to draw a diagram, let's just say of 12 volts, and let's just say that this was R1 and this was R2, you can draw a diagram that looks like this. So this would look like so here you have R1, here you have R2, and here these will be the terminals, and that would be 12 volts. All right, so let's calculate what would the voltage output be. So in this case, this would be the input voltage and let's just say you want to work out the voltage of this resistor. All right, so how would you work this out? First, you need to work out the total resistance. What's the total resistance? R1 plus R2. Because it's in series. This is in series, yeah? So it is in series. So R1 plus R2 is the total resistance. If we use the equation V equals IR, so in this case V is 12 and R is what? R is the total resistance. So what's I then? So the current is 12 divided by the sum of the total resistance. Once you've worked out the current, because it's the same, so here you got 12 divided by R1 plus R2, and here is also equal to 12 R1 plus R2. All right, so you've worked out the current. Now you can work out individually what it is. So again, you can still use V equals IR individually. So individual components. So the voltage across R2 is equal to I, and you know I is this. That's the current, and you're multiplying it by R, and in this case, this R is R2. So this would be your answer. All right, so let's try this question. We have a 270 ohm resistor and a 170 ohm resistor. They are connected as part of a potential divider circuit to a 36 volt supply. The output is connected across the 270 ohm resistor. Calculate V out. All right, so let's draw this diagram. Because it says 270, I'm just going to put 270 here. All right, so what is the total resistance? You add them up, it's in series. So it's 440 ohms. Now we can work at the current. So what is I equal to? Now let's get a calculator. So I is equal to 36 divided by 440. So that is 0.081 recurring. Let's just round it up to three decimal places. So it's 0.082. Once we've got the current, so now that's roughly 0.082. This is also, oh, it's going this direction. So this one is also 0.082. We could individually work this out. So if we have a voltmeter across here, V is equal to 0.082 times by 270. So I've just kept the answer in there, and if I multiply that by 270, I get 22.1 to one decimal place. So V out is equal to 22.1 volts. Now let's try using the formula. So instead of working this out, what's the formula? Now the general formula for this is V out is equal to V input, and you times by R2 over R1 plus R2. That was the general formula. If you go back, remember that the V input, remember I gave the value of V input was 12. But 12, I just made that up. It was just a number. So this is the, in general, this is the formula. So in this case, what's V input? We got 36. What's R2? In this case, R2 is the one that you're looking at. So you're looking at the bottom. So this is R1, R2. And in the question, it says 270. So that's the one that we're looking for. And R1 plus R2 is 170 plus 270. And that will give you, so 36 times 270 divided by 270 plus 170. And that should give you 22.1 volts. So it's 22.1 volts. So if you use the formula, you still get the correct answer. All right, and now what about LDRs and what about thermistors? Let's draw a diagram. So this is the thermistor. And let's just say that you've got a voltmeter across this. And let's draw an LDR. Now, if you remember the graph for an LDR or thermistor. So for a thermistor, as you increase the temperature, what happens to the resistance? It goes down. And what happens for light intensity? So let's just say light intensity and R. Again, it goes down. So as you increase the temperature, the resistance will decrease. And as you increase the light intensity, the resistance decreases. All right, so let's have a look at this. So let's have a look. So this is for this. So as temperature increases, the total resistance, what will happen to the total resistance? All right, let's just focus on this component first. So here we're going to say R1 and R2, isn't it? So if only for this component, as temperature increases, what happens to R2? R2 will go down. If R2 goes down, if we use V equals IR, because R goes down, that means V will go down. So because R2 goes down, then V will go down. So let's just say that's V2. Same thing for this one. As light intensity increases, let's just say that's R1 and R2, then R2 will go down. So as light intensity increases, the resistance of R2 will go down. So therefore, again, if you use V equals IR, so because R2 goes down, then V also goes down because R has gone down.